All right, welcome back. This is part 2 of making a rootkit, where in this series I basically teach you how to go from a kid that knows basic Python, basic Bash, basic PowerShell to essentially make kind of their own droppers, right? That's basically the point that I was, where I would have wished to have these videos. I take you from that point to be able to make the uh, executable that sits at the end, which you would initially get from some random guy on Discord, and which you would use the dropper for, right? Which you would use the dropper for to drop onto the computer. If you haven't watched the first part, definitely do that because I explain a bunch of core concepts. But now we're gonna move on, and this is about avoiding Windows Defender, especially, which, after this video, you could just stop watching the series, to be honest, because everything after that is just complete high-level, super cracked stuff, like doing kernel mode stuff and making an actual rootkit. This right here is just to, having a simple Defender bypass and knowing how to bypass Defender constantly if the bypass doesn't work anymore.
Hey, Editor Jonathan here. Sorry for the bad video quality. In the middle of the video, I'm going to switch to my computer screen, so it's not going to be as bad. I just forgot to put on the autofocus on my camera. I'm going to do that next time. Silly mistake from my side. Also, if you want to join the Discord, we do live calls where I look over your shoulder doing bug bounty, and I also do a live bug bounty, and I just help you with stuff completely for free. We just want to grow a nice community. Then join Discord, link is in the description. Alright, bye.
The first change that we're going to make, because our old executable gets detected instantly, right? Because obviously you cannot just allocate, write, and execute memory without it being detected. The first change that we're going to make is we're going to change our executable from a standalone executable, like an exe file, to a DLL file, to a dynamic linked library. Now, what is a DLL file? A DLL file, you can, if you know a little bit of Python, you can imagine it to be kind of as a library that you import. Now, how you import OS, for example, to execute OS commands on Python, you import a DLL to get certain functions that you wouldn't have to implement on your own, so that you can just use and execute them. So a DLL is just a library that you load into your process. Now, the cool thing about DLLs is once they get loaded into your process, they have a section of code that you can configure that once it gets loaded into your process, it can actually execute some code on behalf of that process. So once you load into that process and you control the code inside of the DLL, you basically control the code inside of the process. This is how game cheats work, where you inject a DLL into the game itself most of the times. Like, not really with high-level games that you need a bunch of more stuff because they usually have kernel-level anti-cheat. But usually you inject your DLL into their process, you hook a bunch of the functions, which we're going to talk about later as well, and now you can execute and change code inside of that process. Now, the thing about DLLs and how we're going to do that, because you cannot just double click a DLL, right? And you can execute a DLL with run32 dll.exe, which is a built-in executable from Windows to execute DLLs, but that's highly suspicious. To actually execute our DLL, we're going to need to find a executable, preferably that's signed, so the trust level from the antivirus is even higher. And we're going to have that signed executable load our DLL. How we're going to do that, I'm going to tell you later in the video. First of all, I want to explain to you how it works, basically. Now, DLLs, there's this problem called DLL hell. DLL hell, right? Like heaven and hell. When Microsoft first created DLLs, they ran into a problem, because imagine that you write a software right now, you use the DLLs from Microsoft, right, the simple functions that you need, and then your program works and everything's fine. Now Microsoft makes an update to one of those DLLs because there's, I don't know, a security vulnerability in it, for example. Now all of your code doesn't work anymore because like some offset changed, and now you don't know, now your program doesn't know where those functions lie, and suddenly, boom, your process crashes every time you open it. Your process completely doesn't work anymore. That's a problem, because now you would have to go and rewrite your complete code to adapt it to the newer version of the DLL, which is super, super time consuming. And with so many different processes and so many different programs that are coming out, like Firefox or OBS, let's see what else do I have open, like Notepad, Visual Studio, Word. All of these programs essentially need DLLs from the operating system. But these all haven't been written at the exact same time. So they don't use the same versions of DLLs as the other processes. Now, the problem here is that you cannot load the same DLL twice, right? You cannot load a same version of a DLL or like a different version of a DLL into the same process. Like you cannot load DLL1 and DLL1 as the second version both into that process, because now you don't know which one to use. How did Microsoft fix that? They implemented the DLL search order, which is an essential part to understand when it comes to also privilege escalation on Windows, persistence on Windows, DLL execution, bug bounty in general. Like, it's pretty important to understand. So the DLL search order is basically, I don't even know what it is right now, like from the top of my head, but basically you have predefined locations where you load the DLLs first from, and if it doesn't exist in that location, you jump into the next location of that list to see if that DLL is there, and if it's there, then you load it into your process. And if it's not, you jump it to the next location. The first location is right next to the own process. So right where you have your own executable, if you try and load a DLL and the path is not hard-coded, like you don't have a C double colon backslash and then some random path. If it's not hard-coded and you just try to load the DLL, it's going to search in the same directory that your executable is in, and then, wait, let me actually look at the search order, because I don't know how it continues. I cannot find it right now. Oh, yeah, well, it doesn't really matter, right? Because basically what we need to know is that, first of all, the first place it looks is where the executable lies. And most of the DLLs from Microsoft don't lie next to the executable. They lie in C Windows System 32 or C Windows System SXS, I think is the path, in the SXS manifest, right? So we can abuse that and just replace one of those with our own, but we don't have to overwrite them. We can just, put our own DLL next to the executable, which usually wouldn't be there. But now that it is there, it loads our DLL instead of one of Microsoft or one of some third party. And why do we do all of that? Like, why do we use DLLs? That sounds so complicated, right? Well, because antivirus solutions, they don't scan DLLs as much as they do executables, and they don't monitor them as much, because that would be pretty resource intense, because there are so many DLLs for one single program. If you go to your directory, if you go to your Explorer, and just go to C program files, and just open a random one, like for me it's, let's open Git. Or Git may be a bad example, but there are a few directories, right? And if you click around long enough, you're going to find some DLLs that get loaded, right? That get shipped with the software itself. And you can see there are a bunch. And for the Windows Defender or antivirus solutions in general to scan every single DLL of those whenever it gets loaded would be so resource intense. So the scan is quicker and it's easier to, bypass than it is with a standalone executable. Now we can abuse the search order to basically get code execution inside of that executable, and bonus points if you find a signed executable that is more trusted initially because it is signed, that is vulnerable to DLL hijacking is what it's called. If you want to do more research on that, because it's a big field, DLL hijacking. If you find a signed executable that's vulnerable to that, perfect. Common example of that was wine.exe for the wine loader. I don't know what APT group used that, but that's basically what the big guys use, right? They use signed executables that load DLLs. Yeah, exactly. So we can abuse that to get code execution inside the process, which is then signed, so it's more trusted, and then we can execute code inside of that process. Right, so we use a DLL because it's harder to detect. Now, the second change that we're going to make is, instead of, like the last video, instead of executing code inside of our own process, like execute camera died again, which jumps into the last DLL, which then performs the syscall inside of the kernel. Now, why does Windows do that? Well, because that way it's easier to detect what the user is doing. Because imagine you call that function and Windows has this, the first DLL, right? And it jumps into that DLL because you call that function. Antivirus solutions now can hook that function inside of that DLL. What does that mean? They can overwrite the first 3 bytes with a jump instruction. So they can basically tell the DLL, hey, if you get a function call, instead of executing how you normally would, just go here, go into my part of the code. So we get into the DLL, and because they overrode it, now we are in the antivirus solution code. And since they got the parameters, right, they proxied the parameters, they can analyze the parameters. Now they can analyze because we already passed the decrypted shellcode to that function, to the write function, right? Because we need to write the actual functioning shellcode to the address for it to be executed. It can analyze that shellcode and do signature analysis again, because it's already been decrypted. So we jump into the antivirus solution DLL, and then it gets analyzed, and if it's fine, if it's a legit program doing legit things, they go back into the DLL that they came from and say, okay, continue as you would normally. And then it goes further down the chain until it reaches NTDLL. Now, that's pretty annoying, right? Do you know a way to bypass this? Well, how about we just skip that line entirely and we just access NTDLL directly, right? And that's basically, in my experience, that has always bypassed the Windows Defender. I do not know if the Windows Defender has its hooks in the upper DLLs right before NTDLL, because I've never actually reversed them. I've only worked with NTDLL directly because, you know, it's just easier that way. Why would I reverse the other two DLLs? That'd be interesting to do, actually. But, you know, Windows Defender doesn't detect that anymore. At least for me, it doesn't. You know, which is leading me to believe that it's got its hooks on the more upper DLLs. So if you just jump into the last one, we can just execute there, and we skip the scanning entirely. Now, if you work against a kernel level anti-cheat, they can obviously change the last one and have the last one jump into their code, right? They can hook the last one. Yeah, exactly. So if we only go against Windows Defender, that usually is enough. How do we do that? Well, we kind of have to understand what the DLLs before that do to then go ahead and use that NT-API function, which is the other keyword that you can do some research on, NT-API, which is basically the API inside of NTDLL. There's a level below this, which is doing the syscalls directly or even indirect syscalls, which is also pretty neat, and that avoids even more detection. But because NT-API for me has already been enough to bypass Windows Defender, which is basically what I'm trying to show you in this video, yeah, we're going to use that. Now, the NT-API, how do you use that? There is a resource that you're going to like, and from this point on, I'm actually going to show you my screen. There we go. Let's close this. Here we go. This is the NT doc. This is a documentation of a third party. I don't even know who wrote this, but this is the documentation of the NT API, which is not documented by Microsoft, right? Because they don't want you to use that. But a few brilliant reverse engineers have reversed the NT API and now tell you how to use it. If you, for example, use NT create thread X, which is just the create thread function, the create thread X function, my bad. We can just look that up onto the on the NT doc, and then just copy the shell, which is basically what we're trying to do, right? We're trying to recreate the shell of that function to be able to call it ourselves. Instead of calling the function inside the first DLL, which calls the function inside the second DLL, we're going to try to mimic that process inside of our own code to basically create this shell to be able to do the call directly. So we need to create that shell for the function to live in, because we don't want to code in assembly. That's what you would do if you used syscalls, which you can do as well. But we're going to do it this way. Now let me show you my code. Here we go. Okay, where's it? We have the NT-inject shellcode function. So this is how you define the NT-API structures, which if you go to the NT-doc, there are going to be a bunch of structures that your operating system, or not your operating system, but that your code base is not going to know, because these are not exported by the DLLs. So stuff like the p-user thread start routine is not going to be known. Now, what are we going to do about that? Well, we can just click on this right here in the NT doc, and then we can just type def it, right? We can just define it, which you can just copy paste this. It's not going to use what a user start thread routine pointer is, so we're going to click on that, and then we are also going to copy and paste that. And you basically go backwards all the way until you have everything defined. So you go to we have here NT create thread X, boom, you just type def it like this. which it's going to return an empty status, right? It's not going to return a handle or, you know, a module like the Windows API functions do. What it does is there are a bunch of in, right? A bunch of in parameters, as you can see here, and there's an out parameter. The in parameter is basically what we pass to the function, and we also pass the pointer, in this case, for the handle to the function as well, which is just writes into that point, right? It doesn't return it as a function, but we pass it as a parameter, and since we pass it as a parameter, we know where to find it. So we define a p-handle thread handle, like a pointer to a handle beforehand, and then we just pass that to nt-create thread, and it's just going to write the handle into that. Yeah, so we copy paste this, right, from the nt-doc, and then we can just see if, you know, PC object attributes is not going to be known as well, and then we can just go back to the nt-doc. Boom, we go onto this right here, and we just copy paste this as well. That's how you implement the NT API. Now, once you have all of these structures and functions defined, then you are at the point where you have the shell ready. Now you have to get the function, the actual function from the NTDLL, and put the function into the shell, right? Which is what we do right here using getproc address, which, you know, it's not very stealthy. There are a few more ways, like obfuscating those strings right here, and then just decrypting them at runtime, and then calling getproc address, or also writing our own getproc address, which basically just you know, looks up the function itself instead of having the Windows API look up the function, which you can, you know, research how to do as well. But since this has been enough for me to execute shellcode, why do that, right? Why fix something that ain't broke? So this is how you put the function into the shell. You use getproc address. You have the module of ntdll, which we get from right here, getMod, which is also just a wrapper function that I wrote because I copy pasted it from another project. You can just get module handle for ntdll. All right, you can just get module handle ntdll, and then you have the handle. And then you just get the address of the function inside of ntdll of this function right here, and put that into openproc, which nt-openprocess goes into openproc, and we have defined nt-openprocess, which this is the type of nt-openprocess, right? We typecast it to this function type, and now openproc is the nt-openprocess function. We do that for everything we need, and then we can use those functions as we would normally as well. You can also just do a comma again to see the parameters and stuff, right? Here we just declare all the stuff that we need, you know, for actually calling this, and then we just call it, and yeah, that's basically it. So what I do is I allocate the memory inside of another process which I created beforehand. So if we go over the general structure, it's, you know, looks for if it's attached or not, you know, like we talked before, if it's the reason to, if the reason it got loaded was it being loaded, not it being detached, then it gets the handle to ntdll. Then we create a process, which is just a wrapper function for create process. If I could find that, here we go. We just use create process to, you know, open a service host.exe, which does network traffic usually, so that's not as suspicious. We start a service host.exe in the suspended mode as well, and without a window, so it doesn't camera died again, so it doesn't get shown on the screen of the user. So we create that process, and then we inject into that process with ntdl. Right. So here we just allocate memory, we write memory, and then we protect it to be execute read write, which I had interpreter shellcode in here before, which needs execute read write apparently. And then we just create the thread. We wait for it to finish, and then we just clean up. And that's basically it, right? It's basically the same thing for as the previous video, just using create remote thread X, which passes a thread handle. No, this is the return thing, which passes as a process handle to know which process to modify it, right? Yeah, it's the basic stuff again. Just instead of having the Windows API to call it, you just skip all of that and go straight into NT API, and that usually bypasses Defender. Like, at least for me, I've never been detected with that. Yeah, I don't want you to copy paste that code directly. I want you to get a little bit creative, because there are also different ways that you can execute shellcode, which is the last step that you do. And this usually is the constraint if your malware gets detected by antivirus. Is basically the order in which you like allocate, write, and execute memory. It's basically, most of the time, is the execution method. There are a bunch of different execution methods that you can use apart from create remote thread, like early APC injection. I'm not going to go into what that is right now, but you can do your research on that. So if that gets detected for you, like this code, which is also pretty weird. It gets detected on some systems, it doesn't get on other systems. Like, it doesn't get detected on my system, and also not on my brother's system. But like, I've talked to a person that copied that code, and it got detected on their system. Like, it's super weird. Also, yeah, Windows Defender is on, right? Real-time protection, dev drive, cloud-based thing. Also, always, if you do malware development, always have this option off, because this option is just going to give Microsoft samples of your code to integrate into that big table that we talked about earlier, to have signatures of your code, so that if you just put it on the desktop, it gets nuked immediately because it's in that signature table. You don't want that. You don't want Microsoft to have your code, right? This is a separate thing. This is for loading drivers, which I had from a different project. But Windows Defender is on, right? And we can try this out right here, which basically the shellcode that I used is the same as the previous video, which it's not the same as the previous video, but I just used Metasploit to, generate x64 shellcode to execute calc.exe on Windows. So and now I can show you as well how to run DLLs if you want to debug them. What you can do is you can just run dll32.exe, which is a built-in exe from Microsoft to run DLLs. Then you specify your DLL to a comma, and then you have the entry point or the function that you want to call from that DLL, which would be DLL main in our case. DLL main. This should work unless I've changed anything. Boom. There you go. There's a calculator, right? And it actually found something. And then it actually didn't find something, right? Microsoft Defender is a little buggy on my machine. It could be that it just, gets detected, but I've tried that on multiple different targets and it didn't, Also because this is a pretty suspicious way to load the DLL, which is also, contributing to Defender to flag this. But as you can see right here, like it didn't really flag it. The shellcode got executed, right? And my directory is not excluded or something, which I can actually show you. I think that's here, and then yeah. Right, so I have the desktop, the temp directory, blah, blah, blah. And as you can see, we're not in either of those. Yeah, so you can just execute this. Boom. Calculator pops up. Shellcode gets executed. There we go. Yeah, that's basically it. I just wanted to tell you the concepts of how to, you know, bypass antivirus. And if that is not enough for you, look into syscalls and what syscalls are, and that 100%, you know, bypasses stuff. Also, the create remote thread is not, you know, the cleanest to use. Yeah, if you have problems with that code, and you know, if you want to look at that code, I'll just, you know, do this slowly so you can pause the video. The decrypt function, like this. Also, what I wanted to say is, if you want to join the Discord, the link is down below. If you have questions, or if your code like doesn't work or stuff like that, make sure to join the Discord. We do live calls, like me looking over your shoulder when doing bug bounty or when doing malware development. I also do bug bounty live there. Yeah, we always love to have new members of the community. And yeah, that's basically it. I'm going to show you the last parts of, you know, the code, so you can not copy paste it. That's why I don't put it in the description or on my GitHub, but so you can look at it and try to understand it more. Because I don't want you to copy paste it, right? I want you to write it yourself. Because you know the concepts now, and writing it yourself is going to teach you way more than copy and pasting it. And I'm speaking from experience here. Right, there's the main function, and that's it. Yeah, that's it. Okay, bye.